So here we have the motor working with 8-bit PWM at 16 megahertz. The oscilloscope is showing us the speed, and it's basically the pulse width which is changing very slowly. Specifically from this distance you should not be able to really see it moving very slowly, but then you may notice the change in speed and even the voice. I'm not going to the maximum speed. It goes up to 240 if I'm not mistaken, and we can see now it's speeding up. Okay, I guess we almost got the idea. So some explanation here should be necessary, I guess. So this green wire is a PWM which goes to the 7th pin of the speed controller, and this is basically the power driver, and this is the pulse width from close look. I'll just wait here that you see that it is changing, but it doesn't become maximum. It's just because of program, that's fine, but it's quite acceptable for now because it's just a trial. So it just goes up to 240, and now let's have a look, simple look to a code. Okay, so this is basically OCR A, whereas OCR 0A, which is the first output of timer 0, and B is the second output, and this is variable A, and every time we are adding 10 integers to it, and we wait for 3 seconds, and then if it was more than 240, we'll just go back to 0. Now I just want to show you the most important registers. The first one that we have here is that the clock value should be 16 megahertz, which is 16,000 kilohertz, and OCR A is basically the non-inverted. OCR B is even like disconnected, but it's fine. And then it's fast PWM. And the only other thing which we have to take care of is that the PWM output, the PWM pin should be considered as output. So we can see here that pin 7, which is basically pin 7, is considered as output, and well, its initial state is 0. So port B is actually a 0, and it's considered as last bit, which is 8 actually, which if you start from 0 as here started, it becomes 7. And that's all important part about the program. Just one more thing for the people who just got started. Well, here is a delay.h, which gives us the ability to use this delay millisecond. Well, we can use delay microsecond as well, which is then microsecond. Example, just 500 microsecond, which is half millisecond. And that's all about it.